How class, in this lesson we're gonna dive into the heart of the computer operation with a focus on the fish decode execute cycle and the key component of the CPU. And let's start with an overview of the cycle. And the fish decode execute cycle can divide to three steps, and which is gonna be the basic process a CPU used to run the instruction, and the cycle repeat continues to execute the program instruction. And here's the brief overview, which is mean you retrieve an instruction from the memory and guide by the program counter, which keep track of the next instruction address. And the next is decode, which is about interpret the fish instruction uh, and break it down into the signal for other part of the CPU. And after you decode it, you will execute the instruction, and it just perform the decode instruction, which could involve arithmetics operation or data move or interact or something like that. And you will see an example in in the in the next slide. And before we talk about the example, let's see some essential component of CPU. And first is a current instruction register, and it is store the current instruction being decoded and execute allow the CPU to process it step by step. And the second is the accumulators, which is temporarily store the data during arithmetic and logic operation, provide a correct and efficient calculation if you in it. And the third is memory registers. Address registers hold the address of the memory locations being read from or write to, and directing the CPUs to correct memory location. And the fourth is the memory data registers, which is store the data just with from or about write to the memory and ensure to smooth the data transfer between CPU and memory. And the last one is the program counters, and it holds the data of the next instruction to be read and ensure the instruction are executed in the correct sequential. And there are some unit and step system code. And first is about the ALU, arithmetics logic unit, and perform arithmetics and logic operation during the program executes, and it handles the task like addition, subtraction, and or operation, and more operation like multiplications or divisions achieved through the sequential of simple operation. And the next is control unit, which is with the instruction from memory and interpret them using the fish decode execute cycle for it, and it generates the signal to synchronize the data flows and program instruction and ensures the smooth operation of CPU. And the first is system cycle, system call, and generates the timing signals to synchronize the operation of CPUs and other components of the computers, and it ensures that all the components work in the correct way. And let's see a basic example. If you want to add two parameters together and store it into an address, we can see the high level languages look like that. Set equals to x add y, but in the assembly language we gonna break it down to three instruction. First we need to load the x value, which is stored in the edges of 5, and after you need to add uh, digital or add instruction, not instruction, integers, add integers, which is y, and maybe it is store it in the edges of 6. So you need to add 6, and after that you need to store it into the set. So you need to know the edges of 7, edges of set, which is 7. So let's see about how is 1 in the program. And first we have the pictures about how it's work, and we will execute the program right here. And we are already introduced about the control unit, ALU, accumulators, and the registers and the program counters. And the right side is about the memory, which is store the datas and the instruction, like the upper part is the datas, and the bottom part is the instruction. And let's run our program to see how it's work. First, we already talk about program counter is store the address about which we need to execute the instruction, which is store the address of the next instruction we need to execute, which is 55. So we need to get the 55, put it into the memory address registers, because you need to with the memory address equal to 51. So you need to put it into these registers, and after that we can use just fetch the data from the memory, which is low 5, which is in the memory address of 51. And after that we're gonna update our current instruction, which is equal to our memory data registers, and is both low 5. And after that we need to remember, after we with the instruction and write it into the current instruction registers, we need to update our program counter, because we already with the instruction, and the program counter is used to remember the next instruction we need to execute, which is store the address of the register. So we need to add 1 to the program counters, which is 52. After we update, we're gonna decode our current instruction registers, which is equal to low 5. And we don't gonna go into the detail about how it decode, so it just break down to the step that need to do, just look like that, because we need to execute the instruction of low 5. So right now we need to update the memory address register, because we need to fetch the data from the memory, which the address is equal to 5, and we put it in the MAR, and we can use the MDR to store the memory, which is the value of the address of 5. So the value is 1, and after that you can put it in the accumulators, which waiting for the arithmetics. And the first instruction of low 5 is finished. And after that, what do you think about the next step of the program? Because right now we already finished the first instruction, so right now we just need to watch which value is stored into the program counters, which is 52. So we just need to execute the 52 instruction, but we need to know about what is stored into the address of 52. So we need to put into the memory address registers, which is 52, and after that we fetch the data from the memory data as the first instruction, but right now it is S6, so we need to update the current instruction registers. And do you remember we talked it before, which is we need to add 1 to the program counter because we already with the instruction, so the program counter will be 53. And after that we need to decode the current instruction registers to the control unit. The control unit will decode the S6, and after that we need to do the S6 step. And S6 is used the memory address of 6, so we need to read the memory or address of 6. So right now you just need to change the memory address registers right here, and after that you can read the memory of the address of 6 and put it into the MDR, which is 2. And right now you need to add the value to the accumulators waiting for the additions. So just put it into the arithmetics logic unit, which perform the additions. So 1 plus 2 equal to 3, and we store it into the accumulator, and the instruction is finished. And after that we just execute the last instruction, which is store 7. And store 7 is in the 53, so first we need to update our memory address registers, which told which address we need to read. And after that we just fetch the data from the memory, which is store 7, and update the current instruction register CIR. And also you need to update your program counters to 54. After that you need to decode your control unit, decode your instruction and put it in the control unit. And after that you need to work with the instruction store 7, so you need to update the memory address register, because you need to store the value into the address of 7. So update the memory address registers to 7, and right now you are not reading the memory from the we not need to fetch the memory from the value from the memory. So right now you need to put something into the memory. So what value we need to put it in? It is the result of our addition. The result of our addition is 3. So put it into the memory data registers, and after that you just put it into the memory, and it will be finished in our program. So this is our class today, and see you